Hey everyone. So let's talk about plastic. It's one of those things, right? It's amazing, it's strong, it's cheap, it's everywhere. But that thing that makes it so great, its durability, well, that's also its biggest problem. It's a real paradox. So the big question is, what actually happens to it when we throw it away? I mean, really let that sink in. Every single piece of plastic that's ever been made is still out there, in some form. When you hear that plastic breaks down, don't picture an apple core just turning back into dirt. No way. It's more like it shatters. It just breaks up into tinier and tinier little pieces. It never really goes away. It just becomes invisible. So, where does it all go? I mean, if it's not disappearing, it's gotta be somewhere, right? That's the huge mystery we're gonna dig into today. All right, so here's the plan. First, we're gonna talk about the plastic we can't see. Then we'll focus on one of the biggest culprits out there. And after that, this is the cool part. We'll look at a wild solution that nature itself came up with. We'll even get into the nitty-gritty of how it works, the roadblocks scientists are facing, and a super clever idea that could be a real game changer. Okay, let's dive right in. We've got to start with a plastic that's so small you can't even see it. It's this invisible invasion that's happening all around us. These tiny bits have a name, microplastics. We're talking about anything smaller than 5 millimeters. To give you an idea, that's about the size of a sesame seed. And they're literally just the shredded remains of bigger plastic things that have been beaten up by the sun, wind, and waves over time. And you might be wondering where they come from. Well, pretty much everywhere. It's not just the obvious stuff like a plastic bottle on the beach. Nope. They're shedding off our synthetic clothes every time we do laundry. They're breaking off from packaging. They're flowing right out of our homes through wastewater. It's kind of crazy when you think about it. They're a constant side effect of just living. And here's the real kicker. Once these little particles are out in the world, mixed into the dirt or swirling around in the ocean, that's it. You can't just scoop them up. They're basically a permanent fixture. And that's exactly why we need a totally new game plan to tackle this. So, okay, if picking them up isn't an option, then what is? Well, to get to the solution, first we have to really understand the problem. And a huge part of that problem is a plastic you see every day, PET. It is the undisputed king of packaging. Oh yeah, you definitely know PET. That's the fancy name for the stuff that makes our drink bottles clear and lightweight and pretty much impossible to break. And all those properties that make it perfect for our sodas and water, well, they're the exact same things that make it such a massive headache for the planet. And just look at the sheer scale of it. I mean, wow. This chart says it all. If you just look at bottled water and soft drinks, PET makes up more than 60% of all the packaging. That's a mind-boggling amount of plastic that's designed to be used for, what, a few minutes? And then it just hangs around for hundreds of years. So why is it so tough? Well, it all comes down to its chemical structure. You can kind of picture it like a brick wall, but on a molecular level. The molecules are packed together super tightly in these really orderly crystalline regions. And that structure is just incredibly hard for nature to break down. But what if something could break down that wall? What if nature found a way? That brings us to the most surprising part of this story. A real breakthrough from a place nobody expected. Okay, this is where it gets really cool. Back in 2016, scientists made a pretty shocking discovery. They found a type of bacteria just hanging out in a recycling plant in Japan that was, well, it was eating plastic. It had actually evolved to use PET as its food. I mean, how wild is that? So how does it do it? It has a secret weapon. It's an enzyme that scientists logically named PETOS. An enzyme is basically a natural tool that makes chemical reactions happen way faster. And this little guy, PETOS, is like a specialized tool designed for one job and one job only, to break apart PET. All right, so we've got the tool. But how in the world does a tiny little enzyme chew through something as tough as plastic? Let's get into the chemistry of it because it's pretty amazing. This is probably the best way to think about it. Imagine the plastic, the PET, is like a super long paper chain. What PET does is it acts like a pair of molecular scissors. It comes along and just snip, snip, cuts the links that hold the whole chain together. And it's not just one step. It's this really clever two-part process. First, the PETA scissors make the first big cut, breaking the long PET chain into a smaller chunk called MHET. Then, a partner enzyme called MHE-TASE comes in to finish the job. It breaks that MHET piece down even further, all the way back to its original chemical building blocks. We're talking about true, complete breakdown, not just making smaller pieces. And you can see the whole thing laid out here. You've got that long PET chain up top. PE-TASE comes in, makes that first cut, and you get MHET. Then the second enzyme, MH-TASE, does its thing, makes the final cut, and boom! You're just left with the basic components it was made from in the first place. You've essentially just unmade the plastic. So, this sounds like a miracle, right? Problem solved? Well, not so fast. There's always a catch. Finding the enzyme is one thing. Figuring out how to use it on the zillions of tiny plastic bits spread all over the globe, that's a whole different ballgame. And this is the heart of the problem, what we're calling the delivery problem. For those little molecular scissors to do any cutting, they have to actually be on the plastic. But if you just dump them in the water, they just wash away. They don't have enough time to get the job done. It's like trying to wash your car in the middle of a hurricane. So scientists have been trying a couple of main strategies. On one hand, you can just spray the enzyme on something. You get a really strong, fast reaction, but then it washes right off. On the other hand, you can try to immobilize it, basically trap it in something like a gel so it stays put. That works, but it can really slow down how fast the enzyme works. So it's this classic trade-off, right? Speed versus staying power. And that brings us to a really new, kind of brilliant idea. What if you could make a little assistant for the enzyme? Something that could deliver it right where it needs to go and then, poof, just disappear when the job is done. And this is it. The idea is to load up the PETase enzyme onto a biodegradable film. Think something made out of simple cornstarch. This film would act like a tiny piece of tape, or a patch, that sticks the enzyme right onto the surface of the microplastic. So the enzyme can sit there and do its work, and while it's breaking down the plastic, the film itself is just harmlessly dissolving. It's like a cleanup crew that actually cleans up after itself. How cool is that? Which leaves us with a really fascinating question. Could a smart, dissolving film be the janitor for our planet's most stubborn mess? It's a powerful idea. And while the research is still new, it's a pretty incredible vision for the future.